So this video is going to be all about making threaded parts, and by the end of it you can make something that kind of looks and acts like this. So actually we're going to be making this exact threaded part set. Alright, so to create these parts, FreeCADweb.org has some information on creating threaded parts. So these threads, we can do multiple things to make them, and if you have standard threads, definitely check out macro bolts here. But we're going to be doing method 3, which is sweeping a vertical profile, and one of the more important things that they talk about is making sure that the profile that you sweep around a helix does not overlap with other profiles. And when we get to that, I'll talk about it. So let's open up a new instance of FreeCAD. And again, this is version 0.17. Actually, maybe not again. It's the first time I'm mentioning it. This is version 1.7, so there have been some changes made to this. Especially the concept of part bodies. And part bodies are a little bit confusing at first. So we're going to create a cylinder, which is going to be the threaded rod. And in this example, because I want to print it, I'm going to make it a little bit larger than you probably see threaded rods out in the wild. Or maybe, I don't know, 10 millimeters not so bad for a radius. Yeah, so we got that. And because we're going to do a swept profile, we're actually going to sweep around the thing. And that is called a helix. So let's do that. So I'm going to go over here to the creation of parameterized geometric primitives. Go to helix. And for this particular part, I chose a pitch of 4. And our height is going to be 40. And again, the radius is 10. So when we do this, we're going to be creating 3 different parts. We're going to create our threaded rod. Then we're going to create a copy of the threaded rod, which is a little bit bigger. And then we're going to create the nut, which is going to fit around the threaded rod. The slightly bigger threaded rod is going to be subtracted from the nut component, and then we'll have the 2 parts that we really want, and that will make sense when we get there. So let's just do that. So with the helix, we'll select it and create a new body, and then with that body we will create a sketch. Now it's important to check these 3 boxes here. And the reason for that is we're going to be accessing some of the helix's geometry when we're creating our new sketch. So let's go back over here and hide the cylinder. Okay, so in order to access that geometry, sometimes we have to create an edge linked to external geometry right here. What we want is that point right here, where the helix begins. And because we're not making anything truly conventional, we're going to make the toolpath, the sweep that we want this thing to follow, to be a complete circle. And again, I'm 3D printing here, so I don't really have to worry about tooling in a lot of the traditional senses. Okay, so now we can go back to the part section. And we're going to want to do our sweep now. So it's utility to sweep. And what we want is the sketch, i.e. this guy right here. As you can see, it's selected. And we want to create a solid, and we want to do a path sweep. So holding the control key, I'm just going down and selecting the path we want this thing to follow on. And again, it's just taking this sketch and then rotating it all around and creating new geometry for us. So I'll hit done, I'll hit OK, and so we have that. So we can show the cylinder and we can show the sweep, and they're 2 separate parts right now. So what we want to do is create a union between these parts. So we're going to do that. Nice. So let's see, yep, that's good. Okay, so the fusion, okay. So this fusion is these two things put together. Now, remember how I said we were going to create 3 parts? Well, this is our first part, and it was probably the simplest to do. But what we're going to do is we're going to create a copy of this. Now, again, the whole body system. Actually, I don't think. Yeah, I don't think I have to create another body. Let's go back to part. Let's try this out. So, because we're going to be creating a copy, and we want it to do essentially a deep copy. So all of the dependencies, we want to copy those as well. So I'm going to hit yes, and actually let's see if I can see, like it wants me to pick something. Ah! Well, let's hit paste. It's not, you see, that's the thing. I don't really want. Yeah, so I might have to create a body. So this is one of the things that is kind of weird. So I need to create a new body. Let's go back to part. Now let's hit paste. Okay, so now this new body that we created is the two parts put together, and now we have a copy of it. But our copy has essentially a deep copy. So, stop it. So we have the cylinder in our fusion, and we have the helix in the body as well. So what we want to do is we want to change two things about this. We're going to make the radius a little bit bigger, and that's because when we create a nut, this is the geometry we're going to be subtracting from the nut itself. It'll make sense when you see it. So this is going to take a little bit. Yep, there's a little bit of a stutter because it takes a little bit of time. So, okay. And the reason I'm doing this is because my 3D printer, while it's great, there are some mechanical tolerances it can't do. So while in theory our two parts, I should just be able to subtract one from the other, the tolerances of my machine that I'm going to be printing this on, it won't print the parts in a way that I think it will. Even if you go to Machinery's Handbook, and you're creating your own threaded rods and screws and such, it'll tell you about like different clearances that you have to have. So we've got this together, we've got our second fusion. So I'm just going to hide that, and we're going to start renaming things because this whole thing is going to get really weird unless you start naming them. Threaded rod. And then this fusion, let's hide that. This fusion is going to be nut threaded rod. Alright, so we're almost ready for actually we are ready for the final component. Let's go to part design. Let's create another body, and this is going to be for the nut itself. So let's create some more geometry. We're concerned about the XY plane. Because we're not accessing external features, we don't need to worry about these. Alright, just because this is going to annoy me, okay, there it is. Go over here. Okay. Now, the nut is just a hexagon. That's centered. And you might be wondering, how do I remember this number? Well, this isn't the first time I've done this project, so I'm going to set it to 35.5 millimeters, which should be okay. So now that we have this, we can pad it so it's 15 millimeters. We can go back to the part, and actually let's take this whole body here, and we're going to move it up 12.5 millimeters. So now we have the nut. It is lifted up a little bit. And let's rename this. Rename nut. So what we want to do is we have this nut, and we have the threaded rod that we made a little bit bigger. So we have these two things. Now we want to take this threaded rod here and subtract it from the nut. So in order to do that, we select the geometry that we want to have other geometries subtracted from, and we'll click this binary, or this union here, or not this union, the Boolean operation. So by having the thing selected already, the nut already selected, it shows up as the first shape. With differencing, order is important. So as you can see, the naming all of a sudden makes sense why we're doing that. so we don't confuse these different things. As you can see, we now have this, and let's rename it final part, final nut, final nut. It's hard to not be juvenile. So we've got that, we got the threaded rod, we got the final nut, and now that we have these two parts, we can see that they go together pretty well. Yeah, I think they do anyway. The only thing that I forgot to do, but you can figure it out, is on the top here, you can see that the helix kind of overruns. Um, I guess you can create a couple parts of geometry to like make this flat rod. But yeah, or you can just change it any way you want. But yeah, now that we have this, we can do something like export this to STL, which my 3D printer is happy with, and you can create 3D printable threaded parts. Alright.